In this video, I'm going to demonstrate that you can use the zeam runtime inside Powder. So the first thing I'm going to do to do this is to clone the repository. And it's cloning. And now I go to the runtime repository and I just zig build. And it's building. It's taking a couple seconds. And when this is done, we just have to check that there is indeed a file in zig out bin zeam runtime, and this is indeed a RIS5 binary. And this is pretty much it for this side of the build. The next step is to go to Powder and to create a directory called output. And then I'm going to use a sub command, which actually I have in the history, which is powdr that uses elf files and transpiles them into their Powder assembly. And I'm going to pass the zeam runtime directory, verify that this exists, zeam runtime, and then tell it to dump everything in the output directory. So now I can check that in output I do have a zeam runtime file, and if I edit it, I can see that there's the machine definition and then the assembly. And I need to do one operation because currently in Powder there's a bug that if you want to prove you cannot use the _start symbol, so I'm calling it not start. This is a step that's not going to be necessary for very long, but it's necessary at the time of the demo. Once this is done, I'm going to verify that I can execute the binary, the assembly file, to check that everything is fine. So I'm going to cargo run in release mode because it's faster. Powder rs still execute output zeam runtime.asm, and this is going to execute. Inside the zeam runtime there's a couple of traces because this is still at the proof of concept stage. I'm just executing a very dummy EVM contract, and it tells me that the run has completed. So this is the output from the zeam runtime binary itself, so it's working. And I need to execute it again using rust log debug, and it's going to do the same thing, but it's going to output some public commitment hash, like the hash of a commitment to the public values, which we need for the verification. So what I'm going to, currently this is not easily extracted other than using this method. There's another branch in the pipe that will let us just write a Rust script to extract this automatically, but it's not completely functional, so at the time of this demo we have to do this. Okay, so we proved that the ISM itself could be executed. So now we're going to go on with the proving. So I'm going to create another output directory that's called output pill, and I'm going to run the proof generation itself by using the pill, Powder's pill command. And I'm going to say zeam runtime, pass it the DSM file, / output is going to be output pill as a directory. And I'm going to say prove with plonky 3. And I'm going to run it, so it's doing the analysis, everything. And I can see my fan, the fan of my computer, speeding up. So it's doing a lot of work. It's taking a bit of time to generate everything. It's a pretty small binary in itself, so it's not going to take a long time, but yeah, because of all the cost of proving everything, it's taking a few seconds. So now I can check in output pill that there's been some things generated, and one of them is the zeam runtime proof.bin. Now I want to verify, and to verify I need to create a verification key. So I'm going to cargo run -r verification key. So that's the verification key subcommand. Using the same source assembly file, I'm gonna say the backend is plonky3, and the directory to use for proof and everything and output is the same directory. So it's generating the key. Once again, I hear the fan of my computer speeding up. And here we go. And it wrote a new file called verification key.bin, which is found in output pill right here. And that we are going to use right away by cargo run verify. So we still pass the assembly again as a parameter. I guess this is also the directory that we generated everything in is also necessary. The backend is still plonky3. I mean, we prove with plonky3. We want to verify with plonky3, and we specify the proof file output pill zeam runtime proof.bin, and we want to use vkey. We specified the verification key that we just generated, and we need to pass the publics, which is what I generated before, but in order to spare you a lot of typing, I'm going to copy paste them because I saved them before. And now it's going to try to verify and hopefully manage to verify it. And we can see that the proof is valid. And just to make sure that I'm not lying to you, I'm going to replace one number with another one, and this time the proof should not verify. So let's see if it does. And we can see that it actually did not verify. The witness is invalid. So this is the proof that verification actually works. And yeah, this is pretty much it. There's going to be a simpler version of this using a Rust script, but currently this is how you can verify for yourself that the proof of concept works.